In example 5 under 4.2, we are told that you can use the angle addition formulae, and we are also told that the addition formulae can be used to find exact values of trigonometric functions of different angles. The word is exact, and this one is going to be seen in example 5. And in example 5, we are told to show using the sign of a minus b, show using the formula sine a minus b that sine 15 degrees is equals to root 6 minus root 2 over 4. The thing is, we are supposed to use the sine a minus b, and we don't know anything else apart from we know sine a minus b is obviously sine a cos b minus cos a sine b. That we know. But because we are talking about exact, we need to ask ourselves, how do we get sine 15? We are supposed to get sine 15 from a difference of two angles. Please note that sine 15 can be sine even 100 minus 85, but we do not have sine 100 is not is we cannot really obtain sine 100 as an exact. But we remember there are those angles that we had dealt with previously, and we had termed them as special angles. And these special angles, which have exact trigonometric ratios, include 90, include 60, include 45, and also 30. So we can say 90 minus 75, that is 15. We can say 60 minus 45, that is, or rather 90 minus 75 is 15. 60 minus 45 is 15. 45 minus 30 is 15. So we can take any, but of course if we choose 90 minus 75 rather, we do not have a special, we don't have an exact trigonometric ratio of 75 degrees. So we are now definitely going to use either 60 minus 45 or 45 minus 30. But do we remember the trigonometric ratios of 60s and also 45s and even 30? Let's remind ourselves, we must now bring in the tool that is going to help us get the exact trigonometric ratios of those angles. One of the very known tools is an equilateral triangle, 60 degrees, 60 degrees, and this is 30, and this is 30, that is 90. If that is true, this has been bisected to 1, 1, and that is also 2. So before we can even go further, we can only get 30 here. So let's talk about what is sine 30. Sine 30 is opposite of a hypotenuse, which is a half. What is cos 30? Cos 30 is adjacent, and what is this adjacent? 2 squared minus 1 squared, that is 3. This is root of 3. So adjacent of a hypotenuse, which is root 3 over 2. It looks like we are going to use something to do with the sign of 45 minus 30. Now that we have 30. So how do we get the 45 angle? How do we get the 45? We can also use 60 minus 45, but either way, we need the trigonometric ratios of 45 degrees. Now, if you look at this, we are going to talk about an isosceles triangle, 90 at that point, one there, and of course we know one of the property of isosceles triangle is that base angles are equal, so that is 45 and this is 45 degrees. So if this is 1 squared is 1, this is definitely the root of 2. So from here we can easily talk about the sine of 45 degrees, which is opposite over hypotenuse, which is 1 over root 2, and the cosine of 45 is definitely going to be equal to this because it's adjacent over hypotenuse. Again, you should also remember that the sine of an angle theta is equal to the cosine of 90 minus theta. That is what we know. So the sine of 45 minus 30 is definitely the sine of 15 degrees, which is given by the sine of 45, the cosine of 30 minus the cosine of 45a times the sine of 30 degrees. Our responsibility is only now to pick these exact angles from our lineup, what we have identified here. So what is the sine of 45? The sine of 45 is 1 over root 2 multiplied by what? The cosine of 30, which is root 3 over 2, minus the cosine of 45, which is 1 over root 2, multiplied by the sine of 30, which is a half. Let's repeat that. The sine of 45, as we can see, is 1 over root 2 times the cosine of 30, which is adjacent over hypotenuse, root 3 over 2, minus the cosine of 45, which is 1 over root 2, times the sine of 30, which is a half. Expanding this, we have root 3 over 2 root 2. That's the left-hand side. Minus 1 over 2 root 2. If we want to now simplify this, we must be prepared to rationalize the denominator of each term. And if we took this one as term 1, we are going to talk about root 3 over 2 root 2. Rationalizing the denominator means we multiply by the conjugate, which is 2 root 2, 2 root 2, both sides. You know how we go about this. This gives us 2 root 6 all over 2 times 2 is 4, root 2 times root 2 is 2, so 4 times 2 is 8. And of course, by 2, 1, by 2, 4. So this is root 6 over 4. What about the other one? The other one, which is now this one, it gives us something to do with 1 over 2 root 2, rationalizing the denominator again times 2 root 2, numerator the same, 2 root 2, which is 2 root 2 all over again 8 by 2, 1 by 2, 4, which gives us root 2 over 4. Now, we remember it was this one minus this one. So we can easily say root 6 over 4 minus root 2 over 4, which is the LCM is obviously 4. And we divide by this denominator, we get 1. So we get root 6 up there, and again minus root 2 up there. And this is, I believe, what you're supposed to have shown. So please note, this is what you're supposed to have shown. So hence, shown. hence shown. And I have used special angles because we needed to use to find exact trigonometric ratios. It's not a must that we should have used sine 45 minus 30. We would also use sine 60 minus 45, and these ones are always here. You can talk about sine 60, which is root 3 over 2, root 3 over 2 times cosine cosine 45, which is 1 over root 2. So you will see when you use 60 minus 45, you will simply interchange the two. But that could be your homework. Please try to solve the same question using sine 60 minus 45, since eventually it will give you sine 15. So we have been able to show that sine 15 is root 6 minus root 2 all over 4. All right?